And this is lecture number. Yes, lecture 6. And I think last time we talked about Doppler effect, and I gave you a general formula. Do you remember the general formula? F apparent was equal to V plus minus Vm plus minus Vo divided by this is the formula that we found last time, na? Yes. But if you remember, this formula is only applicable in the case where the two things, or maybe the source and the observer, are moving along the line joining the 2 points. Na? So if you have the 2 points like this, the source and the observer, then the line joining the 2 points is this, and either your source were moving like this, or maybe this observer was moving like this or like this. These are the possibilities that we considered last time. What if you are making some angle theta with the vectors? What if the angle between them is not this, but rather some angle, general angle theta? Then what to do? So we will cover that in some important points. Write with me. So some important points, and the first point is ki what if the situation that I have already told you, what if my S is here moving with some velocity vector which is Vs vector given like this, and this is here, these are not parallel, then what to do? This is my O. Then the way in which you do this is this, or maybe let's take this to be like this. The way in which you do this is this: you connect these 2 points first. The first step is connecting these 2 points. Then what is the velocity that you care about? You care about that velocity component which is along the line joining the 2 points. Okay? Let's say this is angle alpha and this is angle beta. Then what velocity do we care about in this S? Vs cos alpha. What about this one? Vo cos beta. Then instead, so can you tell me what is the formula that, so if I take the component along this, that will be Vs cos alpha, and the component along this is Vo cos beta. Huh? So it looks to me like the source is coming towards the observer and the observer is moving away from the source. And what should be the formula of it? Can somebody tell me that? Leave Vm. What should be F apparent in this particular case? V minus V naught cos beta. Should I take plus? You are coming towards. If you take the subtraction in the denominator, only then the frequency increases. So it should be cos alpha frequency. This is just an example of a special case, but hopefully the idea is delivered. You take the component of velocity which is along the line joining the 2 points. Yes? So I will not wait around. If you are writing, that's okay. Otherwise I will just go forward. So this is first point done. This is first point. Second point. So let's take this case. I'm going to take two situations and let's talk about that. Let's say you have a source which is moving towards you with a velocity of Vs and you are at rest. We have found this formula. We found it yesterday, and the formula that we found was something like F apparent is equal to V over V minus Vs into F. Is this correct? Please check. Yes, this is the formula that we found yesterday, na? For this situation. Then this can be rewritten like this. I can write it like F apparent is equal to 1 over 1 minus Vs by V into F, and this can be written as 1 minus Vs by V the whole power minus 1 F. And now if I take the case where Vs is much smaller than V, that means the van or the ambulance that is moving is much more slower as compared to the speed of sound, then what can I do here? Then what can I do? Vs by V is much less than 1. Then I can apply this approximation. This is approximately 1 plus x. Yes or no? Then what will I find the final form to be? F apparent is equal to 1 plus Vs by V the whole power f. I will rewrite it again into this form where I will call this Vs to be equal to u. And what is u? I will call the u to be the relative speed between the source and the observer. And why do I say so? Look at this. Vso is equal to Vs minus Vo, na? But what is Vo in this case? 0, it's rest. So that means Vso, which I will call the relative speed, is actually equal to Vs, na? Yes or no? So, and basically I'm talking about speeds, so even if there is a negative sign somewhere, just leave it. So what will you get then? F apparent to be equal to 1 plus u by v into f. This is the formula that I find where my u is the relative speed between source and observer. Is there any problem in this? I think this is very straightforward. Is there any problem with anybody in this? No, right? Let's come back to the other case, which is the source at rest and observer moving. Then what will you get? Everyone has written till here? Okay, I'm waiting 1 minute. Is it done? Yes? Now let me take the case where observer is moving and source is not moving, and I will take the case where observer is moving towards the source with some VO and source is at rest. Yes? What was the formula that we found for this one? We found it to be F apparent, which was equal to V plus VO divided by V into F. Is it correct? Please check. Now this can be rewritten as 1 plus VO by V into F. Yes or no? Now this VO, again look at it. What is VSO or VOS, whatever? What is VSO? Vs minus VO, but Vs is equal to 0 this time. And let me call the VSO to be the relative speed again, that's minus VO. If I take the magnitude of it, because we are talking about speeds, so it doesn't matter. So the speed is just the VO, yes or no? So that means you find F apparent to be equal to 1 plus U by V again into F, where U is again the relative speed. Now you find a remarkable result, and the result is this, that if you remember the F apparent formula that I gave for each one of the cases that we talked about, if you were moving, if the source was moving, your formula was different. If your observer was moving, the formula was different. That means that the apparent frequency was dependent on the individual motions of source and observer. But now I find this result that it doesn't matter if the source is moving or the observer is moving, I'm finding the same answer, and the only thing it depends on is this relative speed. not the absolute speeds, but the relative speed. Yes or no? So this is not true in general, but in some cases it can be true. So we find this result that F apparent, let me write it, that implies F apparent for the case of Vs much less than V is only dependent on the relative motion of SNO and not on the individual absolute motions, of SNO. Do you understand this? Yes? Do you understand this result that we found? That your F apparent is dependent on U, which is the relative speed. It doesn't matter if the source is moving towards you or you are moving towards the source, we are finding the same result. In some limit, Vs much less than V. Good. This was my second important point. And the third one is yes. The third one, should I write it? So I think this was raised yesterday as well, but let me write it as a point now. That Doppler effect or the F apparent frequency that you hear, it only depends on the velocities. No? Once you have the velocities, then you don't have to care about how close the ambulance is or how far away the ambulance is. As soon as it starts moving towards you, the frequency that you will hear is going to be same. Depends on why it will be same. Can somebody tell me that? Do you remember this diagram that I made yesterday? The distance between them, this lambda dash, was lambda minus VST. Na? Since your speed of the ambulance is a constant, this was a constant, this is a constant, so lambda dash is a constant as well as soon as you pick a speed. The lambda dash is constant, that means what? How frequently you will hear that siren ka beep, how frequently you will hear it is going to be a constant because lambda dash is a constant. Na? How frequently you will hear meaning frequency? Yes or no? So that means frequency is going to be a constant. So it doesn't matter how close my ambulance is or how far away it is. As soon as it picks a direction and moves with a constant velocity, it's done. The frequency is fixed. So F apparent doesn't depend on, let me write it, F apparent does not depend on the distance between SNO and only depends on velocities of SNO, and in some cases the relative velocities, not even the absolute velocities, the relative velocities. Is it okay? Good. These are some important points that we have for Doppler effect. Now, Doppler effect, let me ask you this. The F apparent that you are going to hear, is it the frequency of sound? No, it's what you hear it. It's totally dependent on the observer. It's that person who is hearing all of these things. The actual frequency of sound has nothing to do with it. That will be the same everywhere. As long as you have a homogeneous and isotropic medium. Anyways. So it's an observer dependent phenomena. Okay? It's totally an observer dependent. I'm not writing that point, but you should understand it clearly. This is the whole theory. If you don't understand that, then koi meaning nahi hai. Now, there can be some cases where what is the basic understanding that we have? If the source is moving or I am moving, I should find some kind of Doppler effect. This is the basic understanding of it that we have now. But you can have many cases where even if both of them are moving, still you will not find Doppler effect. So let's talk about some cases where you don't find Doppler effect. So some cases where the Doppler effect,
both source and object are at rest, we can find no.
Yes, I will tell you in the point where Doppler effect does not occur. Let me tell you some cases in which the Doppler effect will not occur. The first case can be what if you are at the center of a circle and the ambulance is running circles around you. You are at center observer and my ambulance is moving in a circle with a tangential speed Vs. This is my ambulance, the source. Then can you see that the tangent always makes 90 degree with the radius? And the radius is the line joining the 2 points? Yes? ये मेरा center यहाँ ले लो. तो बताओ, what will be the component of Vs which is along this direction? Vs cos what? 90. And what will that component be? 0. So do you have any kind of motion along this direction? No. So you will not find Doppler effect. Even if you want to write it, you can write it like F apparent is equal to V over V minus Vs cos 90 into F, and since this is going to be 0, so that means F apparent is equal to F. So if the ambulance is running circles around you, you will not find Doppler effect because the velocity vector is making 90 degree with it. And what if the roles are changed? You will find the same effect, na? So you can check it yourself. I'm just making it here. This is my circle. This is my source, and you are running circles around it. And here source यहाँ पर है 90 degree. You can find it here as well. F apparent is equal to F. Does it make sense to you? This is point number 1 in which Doppler effect does not occur even if there is a motion. Point number 2. The point number 2 can be as he raised it. What if the source and the observer are not moving at all? What if the velocity vectors are 0 vectors? If Vs is equal to Vo is equal to 0 vector, then what happens? If there is no motion, still you remember the formula was something like F apparent was equal to V plus or minus Vm plus or minus Vs, नहीं Vo ना ऊपर है, plus or minus Vm plus or minus Vs into F. So even if this is 0, what will you get? You will get this factor, na? But the thing is this now. Let's say you have an ambulance that's not moving, you are not moving, it gives off sound and the wind is blowing in this direction from ambulance towards me. So it will carry the sound. So there will be a speed change. Speed change होएगा ना? But whatever speed change happens, maybe it's supporting the sound wave, then you will put a plus sign here. But you also put a plus sign in the denominator, right? You put the plus sign together, they will cancel, and what will you get then? Same. If the wind is blowing opposite to the direction of sound, minus कटेगा, फिर answer same. So it doesn't matter. So if there is no motion, relative motion, then you can't say all these things.
It is applicable even if it is not equal to 0, right? If they are moving with constant velocity, then also
constant velocity vector, constant speed.
Vector then sign change.
बताता हूँ मैं. F apparent is equal to F. Do you understand? So only the motion of the medium doesn't make the Doppler effect. So motion of medium solely does not result in Doppler effect. Do you understand this? Yes? Now the third point can be, what if the vectors are equal? The vectors are totally equal, then what can you say? Third point is, if the Vs vector is equal to Vo vector, then let's come back to the case that I was talking about earlier. Maybe you are making some angles like this. Acha, when are two vectors called to be equal?
Magnitude and direction equal.
Magnitude and direction has to be equal. That means the angle that you are making with this line has to be equal. Alpha equal to beta. And what about the speeds? They are also equal. So in the formula that I wrote earlier, the formula was something like F apparent was equal to V minus Vo cos beta over V minus Vs cos alpha. What will happen to this formula? ये पूरा cancel होएगा कि नहीं होएगा? Numerator is equal to denominator and you will get F apparent equal to F. Do you get it? So these are the cases in which you will not find Doppler effect. Now we are essentially done with the theory of sound waves, but we will come across this Doppler effect even in light, and I will try to justify the formulas later when we do come in wave optics, but I am giving the formulas just now, okay? Just take the formulas, I will try to justify it later when we go in wave optics. So is it done till here? Done? Are you writing? Okay. So Doppler effect in light. Acha, I will use this symbol C. Do you know the C? What does it mean? 3 into 10 power 8 meter per second, no? Speed of light. Good. So leave two lines here. I will write something here, but write case 1. So the thing is that Doppler effect has in light has nothing to do with the individual motions of source and observer. I will try to justify it later, but I am just giving you the statement right now. It has everything to do with the relative motion between the source and observer. So we will only care about the relative speed. Okay? And I will call it to be V. So what is the formula? So if distance between source and observer is decreasing, then the formula is F apparent is F into 1 plus V by C over 1 minus V by C root. This is the formula. And if the distance between them is increasing, then you can write this to be F into 1 minus V by C this is the formula there. So you just interchange the plus with minus. And there will be a change in wavelength as well. That's given as these are the formulas, and the statement that you should write here is Doppler effect in light depends only on the relative motion between S and O, and V is the relative speed between S and O. Is it okay? With this, the theory of sound waves is done. Okay, now we can move on to problems, and we can actually do some good problems. I have prepared a sheet, but I think papers नहीं है, तो sheet print नहीं हो सकता, तो कल print होएगा, कल ला के दूंगा. I will write some questions today. I will tell you which of the questions are from sheet and which of them you have to write right now. So when you are done, then tell me. Completed? Written by everyone? Okay, then let's start with some questions. Let's start with a very simple question, and then we'll try to increase the level of difficulty. Write this question, okay? Attempt, make your own diagram, and then attempt the question. I will start in 3 minutes. Where's your book? So it's 12:30. I will start. No, it's 12:31. I will start at 12:34. Attempt. Hmm? Then I will explain the whole question.
No, sir. Straight road which crosses car road.
Think. You have to find velocity, na, in this question? No. Frequency, yeah, frequency. What is the frequency you will get? No, it's incorrect.
5380.
Incorrect. 5380, 5000? बहुत ज़्यादा ऊपर चला गया. Should I start? ठीक है, I'm waiting 1 more minute. Incorrect. Make the proper diagram and then the question will become a piece of cake. Okay, then I am starting with the question. Let's understand what it is. A car approaching a crossing C at a speed of this sounds a horn of this when it is 80 meters from the crossing. So maybe you have a crossing here.
Sir, 538.
No. And the car is moving in this direction, right? And it horns this thing with a frequency of this at a distance of 80 meter. This is my car road. This is my car road. यहाँ पे crossing है. And now what is the frequency heard by an observer 60 meters from the crossing on a straight road which crosses the car road at right angles? So I have a straight road and it crosses the car road. ये car road है, ये straight road है. It intersects at an angle. है तो ना ऐसा pedestrian वाला रहता ना एक. 470 is also incorrect. No. So you have a road here as well, na, where the guys can walk, and then ये angle 90 degree पे. Yes or no? And your person is standing here, maybe somewhere, at a distance of what? 60. So here से here का distance is 60 meters, and the person is standing here, and this is my source. 518. Incorrect. ये 80 meters है. Now, if you remember, if they are not moving in the same along the line joining the 2 points, then we always try to find the component along that line. Na? So first I should make the line, and the line is this. And can you tell me the distance, this length? That will be 100 meter by Pythagoras theorem. Let's say this is the angle theta. Then what velocity do we have to care about? The velocity along this direction, na? That will be Vs cos of theta. So it looks to me like as if the source is coming towards me. Then what is the formula that I should put?
V by V minus Vs.
Yes, F apparent will be equal to V by V minus Vs. But what is the Vs along this direction? Vs cos theta into F. And now just substitute and get the answer. So what is V? Velocity of sound 330. Velocity of car? What is velocity of car? 20. And what is cos of theta from this triangle?
3 by 5.
That's 80 by 100, na? That's 4 by 5. Yes or no? From this triangle, that's cos theta. So that will be 4 by 5 into f. And what is the frequency? 500. So I think you can do the calculation very simply. The 4 4s are 16, 330 minus 16 is 314. The 330 by 314, what is that value? Can somebody tell me that? ये 1.0 कितना आ रहा है? 6 है या 9 है, क्या है? 1.0 वॉट? 003 1.05 अप्रॉक्सीमेटली ना? हाँ चलो छोड़ो, उसके बाद 100 से मल्टीप्लाई कर दो तो 105 इंटू 5 दैट्स अप्रॉक्सीमेटली वॉट? यहाँ से ये अप्रॉक्सीमेशन दैट्स 525 हर्ट्स आई थिंक. Is it correct? Please check. This is what I found. How many of you got the answer independently? After I started with the solution? Good. Okay, good. So let me write the next question if it is done. So try to imagine everything. Only then you will get it. Can I write the next question? Please don't waste time in writing the question, so please write with me. Don't talk around and then give the time for solution. Yes. Attempt. I will start with the question on 1247. Don't sit around, attempt. Try to at least read the question and write whatever you can as a given data or make the picture. Five? 594 for what?
Sir, both are same. Highest and lowest frequency.
No.
I took minus in the denominator, so is it highest or lowest?
I don't know. You tell me. 5?
Sir, highest is 540, 594.
Highest is 594. And where will that be formed? On this circle?
Where if for example the observer is here.
Arey, observer is not moving.
No, this at rest. So he's not.
Is the source or the horn which is moving performing circular motion? उसकी ये velocity कैसे आ गई? उसकी तो tangential velocity होती है. हाँ. तो ये है highest frequency का point.
हाँ.
ये है?
हाँ. So because the distance is lowest.
अच्छा.
I get it. This will be the.
What this will be? I just wrote it somewhere. What are you making here? So the highest
Point. At this point, and at this point. No, only at this point. At this point, it is opposite. So at this point, it is highest. At this point, it is lowest.
This point is the lowest.
And this point, because both are negative.
What will be about this point?
This is negative, like
तो?
direction. ये add हो जाता है.
ये add होएगा इधर.
VS will get added.
VS will get added तो क्या होएगा फिर?
Denominator
Frequency.
will be highest. So
हाँ.
overall frequency decreases.
हाँ तो?
So this is not maximum value.
This is maximum.
This is
This is the least you are saying.
No, I should check between these two.
बोलो.
Sir, lowest is 491.4.
कहाँ पर होएगा मुझे ये बताओ. ये सब मुझे values मत बता.
594.
Where should it be formed? Tell me.
There in the same place, the observer and the source.
Sure.
When the source is over here and the observer is stationary over here,
अच्छा तो
and when the source is rotating, the point when it's over here will be the highest.
तो बताओ ये जब सोर्स रोटेट करता है तो उसकी वेलोसिटी बाहर निकलती है या फिर टेंजेंट के साइड चलती है?
Tangential like this.
ये कैसे निकल गई? टेंजेंट ना?
Ah, yeah. So it will be tangential.
टेंजेंशियल. तो ये एंगल कितना बना रहा है?
Okay, so at this point, sir.
हाँ?
At this point.
At this point it is minimum, at this point it is maximum, at this point and this point it is F apparent equal to F.
Good. I got the answers. Anybody else? इधर क्या चल रहा है बताओ. It's already 12:48. Should I start? Or should I wait? 1 minute? ठीक है रुक जाते हैं. हाँ चरण आंसर आ रहा है. Imagine what is happening. हाँ भरत डायग्राम बनाया. Yes obviously like this. अब बताओ कहाँ पर क्या बनेगा.
Apparent will be maximum.
Where is your observer? अच्छा ये तुम लोग बोल रहे हो ये सोर्स कैसे ऐसे गोल गोल घूम रहा है ना, तो ये इधर वेलोसिटी कैसे आ गई? वेलोसिटी टेंजेंशियल होगी ना. अब सोचो कहाँ पर मैक्स कहाँ मिन कहाँ पे चेंज नहीं होने वाला है. यस, वैल्यूज से मुझे कोई प्रॉब्लम नहीं है, मुझे ये बताओ कि कहाँ बन रहा है, दैट्स मच मोर इम्पोर्टेंट। वो जो तुम लोग बोल रहे हो ना वो भी अप्रॉक्सीमेटली करेक्ट है, दैट्स नॉट एग्जैक्टली करेक्ट। अभी मैं एग्जैक्ट बताता हूँ। नाउ लिसन टू दिस, व्हाट इज द क्वेश्चन आस्किंग? You have a vessel of this frequency rotates in a circle of this with a linear speed of this. What is the lowest and highest possible thing? So now your source is performing a circular motion, na? And where is your observer? Far away from the center. So it could be anywhere. Let me take it to be on this direction. So ये इसको, this is my circle. This is my circle. Let's say my observer is sitting somewhere here. This is the center and the distance between the observer and the center is huge. ठीक है? Now the thing that you are not understanding is this, ये जो source of sound है ना, the whistle will perform circular motion, that means it will have tangential velocity. If it has tangential velocity तो ऐसा ऐसा होएगा ना? These are the possible tangents. Yes or no? So now when it passes like this, let's say I'm assuming it will perform this clockwise motion बोला, तो there is a possibility here, here, here and here. Yes or no? Now look at these velocities. If I call this point to be x, y, z and w, these points, huh? Now look at w and y. What are the angle that they are making? That's 90 degree, na? If your velocity vector makes 90 degree with the line joining the 2 points, then will you have any change in frequency? I just told you, no. So what is the frequency? Frequency or f apparent is equal to f at y and w. And this is the last part of the question, no? Will the f apparent ever be equal to f? That will be equal to f in these 2 points. Where will it be maximum? So look at the points joining the 2 particles, the 2 things. So if I take this and this, then this is the line joining the 2 things, huh? Yes or no? Let me make it a little better. Then the component of the velocity should be like this, not even like this, but rather a little tilted like this. And when you have this situation, only then will you find maximum, because your velocity is going towards the source. Yes or no? Where will you find minimum? When you are moving away from it. So एक point ये ले लो, and now your velocity is like this. So it's not even exactly like that, like this. अच्छा, when will this approximately be equal to this? When the distance is huge. When ये इसको ऐसे scale करोगे ना, तो ये approximately ऐसा दिखेगा, है ना? It will look exactly like a tangent. Anyways, what will be the velocity at x, or the frequency at x? That will be v over v minus vs into f, na? At x. At x. And what is the value that I'm not doing the calculations? You tell me, what is the value you are getting? 594 hertz. What about at z? What is the frequency? That's v over v plus vs. And what you are getting now? As simple as that. So you have to understand in which direction will the velocity vector will be, so that it will look as if the siren or the vessel is going towards the observer, and that is this. And where will you be away from the observer? Exactly away from the observer? This. है ना? So those are the cases, and that's the question. Very simple question. Yes, yes.
You said they were the exact values.
Exact, वही तो मैंने बोला. You are making this, ना? It's exactly like in the limit that you are taking, stretching it, then it will look as if you are making that. ठीक है? Is it okay? Can I write the next question? Don't talk. Attempt this one. This is a little interesting. Attempt. I will start at 101. Giving you 4 minutes. 330. Take 330. No, take 340 rather.
What if we take? What if we do it taking 330?
No, it's given in the question. I did not write it here. But velocity of sound to be 340. I forgot to write it. 340 hertz लिख दिया ना, 340 मीटर पर सेकंड. Incorrect. Anybody else with the answer? If you do it exactly, na, you will find a quadratic. Or not even long. I don't know why it's giving wrong answer, but it will give you a wrong answer if you do it exactly. But if you understand the question and understand the approximation that can be made here, then you can get the answer. There's an approximation that you can make here. Should I start with the question? Okay, I'm waiting 2 more minutes, then I will start. Take the you're doing by quadratic, na? Should I start? 77066.68. इतनी high velocity हो ही नहीं सकती. You are going even farther than the speed of sound. कितना टेंस ऑफ थाउजेंड से ज़्यादा, वही तो प्रॉब्लम हो रही है, कुछ एग्जैक्ट मेथड में कुछ प्रॉब्लम हो रही है. आई डिड इट इन 2 other classes as well. I am getting the same problem. But if you do the correct approximation, then you won't get the problem. अभी करके दिखाऊंगा मैं. No. Let's do it. कर रहा हूँ रुको. करेक्ट मेथड से तो मुझे राइट आंसर नहीं आ रहा. देखते हैं अभी. Whatever I am telling you, listen to that. You have 2 tuning forks and they have the same fundamental frequency. They are moving towards a stationary observer, but they are moving in the opposite directions. If I have the observer here, then one of the tuning forks is moving in this direction, and one of them is moving in this direction. Yes, they both have the same fundamental frequency, 340 Hertz. But when they start moving, due to Doppler effect, their frequencies will be changed. Maybe this frequency becomes F1 and this frequency becomes F2. Yes or no? One fork moves this. They both move with the same speed. And can you already tell me what is F1 equal to? That should be, since it's moving towards the observer. 1.5 is correct. V over V minus Vs into frequency, right? This is F1. What will be F2? V over V plus Vs, है ना? और Vs का मैं V tuning लिख देता हूँ. V tuning fork. Is it okay? F1 and F2. It's given that F1 minus F2. अच्छा, which of them will be greater, by the way? F1 will be greater than F2. So F1 minus F2 is given to be 3 Hertz. This is given. F1 minus F2 is equal to 3. Now understand this. F1 minus F2 is going to be 3. Acha, whatever, let's take some values. Just for example's sake, let's take, when you go away from the source, maybe your frequency has decreased and maybe it became 338 point kitne se ho raha hai 5, just for example. And when you go towards the observer, then your frequency heard is 3 kitne se 1.5, so फिर 1.5 again. And now can you see the difference in frequencies is 3? I have just taken one example. There will be a change here, there will be a change there, and this is what I am saying. What is the change? The change is that बहुत बड़ा है क्या? The change is not that big. That means what? कि this thing V over V minus Vt या फिर V over V plus Vt is not a big number. This is approximately equal to 1 only. है ना? This may be a little greater than 1, a little greater than 1. This will be a little less than 1. If that is so, then what about Vt? The Vt is relatively much more smaller than V. Only then you can say this statement, right? That your 1, this is a little greater than 1, this is a little less than 1. So your Vt is much smaller than V. Then what approximation can you do?
V equal to V
Binomial. You can apply binomial. If that is so, then what can you write F1 to be? Then F1 can be written as 1 over 1 minus Vt by V, the whole F. और उसके बाद binomial लगाओगे तो 1 plus Vt by V into F. And likewise, what can you write F2 to be? This you can write it binomial approximation के बाद. Then let's substitute and let's try to get the answer. You won't get a quadratic now, you'll get a linear equation and the question will be done. So F1, 1 plus Vt by V into F minus 1 minus Vt by V into F, that's equal to 3. अब बताओ ये first factor तो गया, तो I think you will get 2f Vt by V is equal to 3. अच्छा, velocity of sound and this fundamental frequency are same, हाँ? तो ये कट गया, तो फिर Vt कितना आ रहा है? And this only makes sense that कि velocity has to be very very small, not like tens of thousands. Yes. But the thing is, if you were to just put this into this equation, becomes a quadratic and then gives you a huge number. I don't know why.
Sir, but generally accurate method should be the right answer.
सेम आ रहा है? हाँ हाँ, वो tens of thousands में आ रहा है ना? I did it as well. I am getting the same thing. I don't know why. 5 digit पता है, क्या पता, चेक करना पड़ेगा मुझे. But I think, did you understand the logic here? Huh? You have to understand yourself. What, how do we? Copy the solution. Virupaka. We did the same way. Good. अब बोला तो लॉजिक तो बताया कैसे करना है. मुझे पता है, मैंने किया है, मैंने भी 2 क्लास में मैं करके आया हूँ.
V square minus V naught square is approximately equal to 340 square, because we know that V naught is so low.
हाँ, तो V naught is so small. If you can make that thing, if you can understand that, then why can't you apply that? ये तो मैंने बोल दिया V naught is so small, then you are saying ना V naught भी नहीं होना चाहिए, Vs होना चाहिए. हाँ हाँ,
Did they do by this method?
इसी मेथड से किया. So these are the simple standard questions that you should know. अब हम लोग शीट के क्वेश्चंस करेंगे, बट शीट है नहीं, तो शीट के क्वेश्चन मुझे लिखने पड़ेंगे. तो तुम लोग मत लिखना. You don't write the questions, you will get the sheet tomorrow. You just understand the question and attempt it right now. And write sheet number 1, question number 1. ठीक है? So don't write the questions, you will get the sheet tomorrow. तो चलो क्वेश्चन करते हैं. बोलो. चलो. This is not homework. Only 4 minutes? 7 minutes है ना? अरे तो you do the question just while I am writing. Anticipate what I am going to write next. Okay, don't have to write the question, just attempt the question and If you're able to do it in the given time, that's okay. Otherwise, I will do it tomorrow. Attempt. अभी 5 मिनट बाद ब्रेक मिलेगा ना? चलो, somebody tell me the length. He can switch off the video.